And so here's what I want to do. Let's say that this was the specific question we were working on, this exact graph, and it wanted us to find dy dx. We would have some kind of an equation for this. It would be r equals some function in terms of theta. So this one would maybe be like 2 plus 3 cosine theta, or something like that, right? So I'm just going to say, like I did up on the board there, I'm just going to say this is just some function in terms of theta. I'm not going to really worry too much about exactly what it is. I just know that r is in terms of theta. That makes sense? And then the way that I develop it, if I'm going to find dy dx, I need to know how x, r, and theta all relate, and y, r, and theta. So those are your relationships. Just like physics, if you've had a physics course, x typically goes with cosine and y goes with sine. It really is the same kind of thing. And then let's remember that dy dx equals dy d theta over dx d theta. That's just based on the fact that a polar graph really is just a parametric graph, but instead of t being the parameter, it's theta being the parameter. But it's the same process, right? It's the same kind of thing we used with parametric and really even vectors as well. So if I've got to find dy d theta and dx d theta, I have those right there. I could expand on them a little bit. You could write x is equal to f of theta cosine of theta. Y is equal to f of theta sine of theta. You could write it out like that, and that would serve you well, basically like what we did up here. So I will use the stuff here in the green box to help me do what you guys just did. So it would be dy dx equals dy d theta over dx d theta. Of course, you guys all did a nice job. You got to use the product rule twice, right? It's going to be 1 d2 plus 2 d1. So 1 d2 plus 2 d1. And then down in the denominator, it's the same thing. So it'd be 1 d2 plus 2 d1. And yesterday at the end, I gave you guys a word of caution. I've seen perfectly good math students that otherwise know what they're doing. Every now and then I've seen them try to do stuff like this.
Oh, wow, that is really upsetting.
Or,
That would be so nice.
like that.
It doesn't work.
Or even worse. Are you ready? This is worse. Oh, this is so much worse.
Oh, yeah.
Or you could try to factor out a theta squared,
Oh, that'd be crazy.
right? Because anyways, there's all kinds of ugliness that could happen, none of which should happen. So please resist the temptation.
Forgot about canceling
It's-
out the signs as well.
Well, yeah, we could have. One of them was negative, so we ended up with a -1, but right? Yeah.
You can just cancel out the negative. You don't need it.
Well, let's just cancel the whole thing out. Just say it's all just -1 or something. And just, yeah.
Oh,
Anyways,
over 0.
it's just one of those expressions that's just going to be sort of complicated, and that's just it.
It's just indeterminate.
Just indeterminate. Yep, 0 over 0. It all just adds out. Anyways, so what can you do with this? There's a number of things you can do with this, and we're going to practice maybe all of them today, or maybe most of them today, and then the rest on Monday, something like that. But I thought I'd just give you a quick illustration. So here is a way that a question could be worded. It could say something like, find the equation of the tangent line when theta equals, I don't know, pi over 4. Something like that. When theta equals pi over 4. So here is what that really means. When theta is pi over 4. So right now, if I were to sketch this in, I'll do this in a brighter color. What would you guys say theta is when I'm facing that direction? 0.
Okay.
Totally.
It's like, is this
Okay, so
a
that's
question?
not exactly what this question is asking about. It wants to know what's going on when theta equals pi over 4. So that would be roughly that. 45 degree-ish, halfway between the x and the y-axis, something like that. And I don't, who knows exactly what this graph is. But wouldn't the tangent line look something like this red line.
Oh,
I'm off by a little bit, but you get the idea, right?
yeah. Stick person?
So if it's a circle, yes. It's not a circle, probably not. Yeah.
What was the question?
He asked if well, you say, Nick.
I was wondering if the tangent line and the line drawn for the theta are perpendicular.
It's a property of a circle, but not necessarily of a limacon or a lemniscate or whatever. Okay, so then I just want to remind you, if we were actually going to do this question, which we don't have enough details to do this, and come to like an analytical answer, but if we were, what would be the two things that we would need to get to this equation of the tangent line? Say again? Well, theta is pi over 4. So we'll definitely use that. We need the slope
And the point.
and the point. So we need to know what is this point of tangency. So we'd need to know, all right, what's the x comma y there? And then we'd also need to know the slope of that line. If I had those two things, I just use point slope form and done, right? So what do you think we would do if we were going to actually do this and we wanted to figure out the slope? What would we actually do?
Find f of theta.
So I would need f of theta to do that. I'm just talking theoretically. If I did have that, which I don't,
You would plug your f of theta into
I would plug f of theta into what?
dy dx to find.
Right, yeah, so at this stage, like if I knew exactly what f of theta was, it would be there, and then the f prime of theta would be there and there.
And then you would
So why can't you answer this?
You just plug theta into f.
put the pi over 4 in there.
Yeah, I need to plug the pi over 4 in, right? So I would need this. I would go dy dx evaluated at theta equals pi over 4. So I would just be plugging in pi over 4, 1, 2, 3, 4, 5, 6, 7, 8 places, right?
That's logical.
So I'd plug in pi over 4, and I'd do some unit circle work, some evaluation, whatever that entailed, and I'd come up with some number, wouldn't I? I would come up with slope.
Great.
Okay, so I do all that work, I get slope, but I need to figure out the point. How would I figure out that point of tangency, that x comma y?
Well, we have x r cosine theta.
Yeah.
Y equals r sine theta.
Don't we have this right here?
Oh, we have that.
So what would I do with that?
You would plug in.
Plug things in,
Plug what in?
the function in,
Yeah, I'd plug the function in, whatever f of theta is, I'd plug that in, and then I would plug in
the theta
pi
function.
over 4.
theta equals pi over 4, right? So the pi over 4 would just go in all these 4 places. I'd come up with an x, I'd come out with a y, and then I'd just go to point slope. That makes sense?
That's a lot of effort.
It is a lot of work. So these questions don't take like 1 minute and 3 seconds.
Unit circle.
Yes, I told you it would involve a lot of unit circle.
Those area ones are
So the area ones are actually faster than this, I would say.
really?
You probably use it.
We're going to use a nice, tidy little formula that we'll talk about where it comes from, and it'll be good.
So
I'd say the area usually goes by a little faster.
We need sort of like point slope for r and theta, like
Well, so-
r minus.
Not really, because the equation of a tangent line is always going to be y's and x's,
Yeah.
right? So, you're wanting to kind of find like a parallel.
Yeah.
Like, what's the r and theta version of this tangent line? I mean, we could get a final answer with y's and x's,
Yeah.
and then we could convert that over to polar, right? Because you can draw a line in polar, but it would just be like an interpreted version of the original
Yep.
thing. It wouldn't be anything unique necessarily.
Okay.
And you would think, why am I doing all this work?
Yeah.
Because it really is the same thing. Yeah. Yeah. Jack, go ahead.
Are we ever going to rotate something like that? And we'll rotate it around the line and find the volume of it?
So that's doable. Let's see here. So it's pretty crazy. Let me just think for a second here. So you totally can, but you would probably, it gets ultra complicated, and you would end up using this thing called the theorem of Pappus. And the theorem of Pappus is essentially like if you have some shape like this and it's not conveniently written out like a washer method or shells or discs or whatever. The theorem of Pappus says that, I got to think about this, if you can find the centroid of the region, which would be the theoretical balancing point, like center of mass, right? And we're rotating, like you said, right? So if you can find the length of the rotational arc created by that rotation of that centroid, that's equal to, I believe, the volume
Wow.
or surface
Tuesday.
area. It's been like 20 years
Hello, everyone.
since
Sorry
I like
for the interruption.
studied this.
Just wanted to advise you that as a precautionary measure, Valor will be going on lockout for an event that has happened near the school. Please be advised, we'll be going on lockout. That means no one is to be outside on the exterior. You can go ahead and carry on business as usual on the interior. The administrators will be standing at all the doors. We are only on lockout as a precautionary measure. Thank you.
Yeah, whatever it is, it's out there somewhere. That's good.
For now.
So, for now, yeah. So, Jack, that's a half answer to your
I
question.
was just curious.
Yeah.
As long as we don't have to do it.
Oh, no, it's nothing we're going to be doing in this class, but it's
I think it's a bear.
nonetheless interesting. It's, I don't know, I'm trying to think. There was a couple of classes I took in undergrad that were like, they were either grad or undergrad. Like there was kind of a mix of like juniors and seniors and then like people that already graduated. It was one of those classes that could kind of go either way, and that was probably what it was. I'm trying to remember what that class was even called. Yeah, anyway. Okay,
Where'd you go to college?
Florida,
Yeah, oh, Florida?
University of West Florida.
For both grad and...
No, right now CCU is where I'm getting the master's from.
Okay.
Did you have a master's degree?
Got one class left.
That's so exciting.
Almost there.
7 weeks. 7 weeks, and then
We're graduating.
so seniors.
Oh my gosh, we're gonna graduate at the same
We are. It's true. Yeah. So seniors, like when you're feeling like I just want to be done and all that stuff, I'm feeling the same way. I totally am.
I just want to be done.
Somebody suggested that, and I'm like, I need to like wait a little bit. I don't know about that.
Just gonna see.
But I promise you, I'm not gonna like, wimp out ahead of time and just mail it in, or I am not gonna email the professor and say, hey, I've got a 94.1. What's the lowest I can get on the final and still pass, or all that stuff. I'm not gonna do that either. So
You and Nick can do a grad party
Do
together.
it yourself.
Yeah.
totally good. My wife really wants me to have a graduation thing. She's like, you need to go walk, and I'm like, I really don't want to.
That's so cute.
And I'm like, so I think.
You should invite us.
Say again.
When are you gonna graduate college again?
Yeah,
You know,
this is
it
the
Yeah.
could be the
last
last
time.
thing.
It could be the very last time. Yeah, that's what it says.
Celebrate it.
Celebrate.
Yeah,
Last
nobody-
time you ever graduated.
We all gotta get a
Last
picture
time you
with
ever
you
did.
at graduation. That would
We
be so
totally
much
should.
fun.
We totally should. I'm down. Yeah,
Sweet.
I'm down. It's been a good journey. It's
Hello, everyone.
been
Thank you for your time. Please be advised, the lockout has been lifted. The lockout has been lifted, and the situation has been resolved. Please go about your normal business. Thank you.
I hadn't really thought about a graduation party, but you guys are coming up with some really good ideas.
Or you could just like celebrate with your VC class.
Say again.
You got some donuts in there.
Oh, yeah.
That's a good idea. I'll even bring the donuts to my own party because it'd be be like your guys' party too.
Yeah, it's gonna be all of our graduation party except for Sam and Aiden because they're losers.
So that means they don't get.
They're honestly the biggest winners here. They're
Yeah, let's be honest.
So now you're gonna need someone to drive me there.
Aw.
Aw.
All right, guys, flip over to the next page. We'll use this a little bit.
Literally just
there.
You know what? Meg is gonna be watching this and just having the time of her life.
Yep.
I hope your wisdom teeth are feeling better.
I'd rather just got his wisdom teeth out.
It's rough.
That comes with
rough.
one condition.
Hey, so based on your guys' good work here around the room, and then what you saw last time, what you saw this time, what do you guys think would cause a horizontal tangent line?
Horizontal.
Horizontal.
Zero slope.
The top is
dy is 0.
Yeah. So if the numerator of that, dy dx fraction, right? So this would be if dy d theta is equal to 0. So if the top of the fraction, if the numerator is 0, got a horizontal tangent line.
Are there any parameters relating to dx d theta on this?
Yes. What do you think would cause a vertical tangent line?
Well, I'm talking about.
Yeah, we'll come back around to that in a second. Yeah. So this would be if dx d theta is 0. So then you got to go back and say, oh my gosh, what would happen if they're both? And so we have to kind of go back up to this and say,
Oh my God. we have to
well,
do
no,
product
no.
rules.
no,
Imagine.
we're not doing a limit. Like we're not doing that kind of limit. So what you would do is you would say, for there to be a horizontal tangent line, dy d theta has to be 0, but dx d theta isn't 0. And down here, for a vertical tangent line, you'd say dx d theta is 0, but dy d theta isn't. So what if it's both? Yeah, so if both, so I'll put if dy d theta
Oh, shoot.
and dx d theta are simultaneously 0, so they're both 0 at the same angle, then no conclusion can be drawn. So what does that mean? It could be a sharp point. That's a really common situation. Just means that there is no tangent line, right? Sharp point means that the dy dx is undefined, and you can't draw a single tangent line in there, right? It also might mean that the original graph itself simply doesn't even exist there. It might just be a blank spot in the domain, more or less. Most of the time for us, it's going to be the sharp point thing, and we'll see that come into play once or twice, maybe. Yeah, Jack.
Do you think maybe, just maybe, we could evaluate the limit
Yeah.
at dy dx and then do a bunch of L'Hopitals to figure out what it actually is?
Well, if you want to, if you want to, it would involve. If you think about it, it could potentially involve like an ever-expanding product rule,
Oh.
right? Because the product rule produces two products, which then would be like a geometric growth of product rules. There was 1, and then there was 2, and then there was 4, and so on.
Would try and do that.
Okay, so guys, let me give you a brief word of caution on this one. If you are the type of person that writes in letters that are measured in like inches high, like large letters, don't, because I'm going to do more than one thing with this, and I want you to have room to write, and there's enough going on as it is, but I would like to do more than one activity with number 1, even more than's listed up there. So I think the first thing I want you to do, just so you can kind of get a sense of what this is, grab your calculators and graph this, okay?
Oh my
And just get a little sketch of that graph on there. Sir?
So what's a good reason as to why dx d theta and dy d theta can't be 0 for those
So that gets into like a 0 in the numerator, a 0 in the denominator, and that's just indeterminate,
Gotcha.
right? And so you look at it and you're like, well, I don't know exactly. Is it vertical? Because it's a contradiction, right? Because the numerator being 0 indicates horizontal, the denominator indicates vertical, but it can't be both. So which is it? We don't know. We don't exactly know.
It's all at once. Never came.
It's a sideways one,
Oh, how cute.
I think.
A sideways heart. Yeah.
It's a cartoid.
Party.
But the big part's on the left, isn't it? Big part's on the left. So it looks...
That exposed me.
Cartoid, did you call it
I called it a cartoon.
Oh, that is so not a good one.
That is bad.
I will let you.
Terrible.
I'm not gonna lie.
I tried to do it in one effort. I'm not even going to try to finish that one. Okay, we're going to start there.
We're laughing at you, Nick, not with you.
All right, we're going to call that good enough.
Looks like a
It looks
kidney.
like a. Oh wow, mine looks more like a heart than that.
So yeah, looks like a cardioid. Let's make some predictions here. How many vertical tangent lines do you think you're going to find?
2.
2. Okay, so one of them is over here, and you think the other one's over here. And given symmetry, you'd think that vertical one would be tangent to both of those little bumps on the side of the heart there.
Yeah.
Okay. How about horizontal? What do you guys predict about that?
Dose.
2, okay.
No, don't, no trace.
Wait a second.
I won't keep going.
Quick question.
Go ahead.
Deal or no deal?
Isn't there 3 vertical tangent lines?
So yeah, do you hear what Jack just said? He said, could there be 3 of those verticals? Why would you say 3?
Because there's 2 separate points there's 3 separate points on the entire function
So that's an obvious one, right? The yellow one.
where,
And then you're saying this one here and that one there.
yeah.
Okay.
Well, it depends if we're talking about tangent lines or if the dy dx is.
So this says find locations of all horizontal and vertical tangent lines, locations. So if we feel like there's 2 different locations over there, maybe that's going to matter. Okay. So let's hash this out.
I think there's one
If,
simultaneously divided.
hey guys, listen up please. If we're going to find horizontal tangent lines, what do we need? What would we need first? We need dy d theta, and we need to figure out a little bit about dx d theta as well. If we're going to find those 2 things out, what do I need to do before that even?
Find y in terms of theta.
Yeah, got to get my y and x in terms of thetas instead of just r in terms of theta. Yeah. So you could distribute the 2. That might be helpful. So it'd be 2 minus 2 cosine theta. But then we're going to go back to that same thing we were working with all around the boards to start our class. We'll say y equals r sine theta. And then I'll go with a different color. X equals r. Oops. Cosine theta. Okay. So if we're going to be setting dy d theta equal to 0, like we said a minute ago, or dx d theta equal to 0, we're going to be working on derivatives of both of these. And I'll let you guys kind of work through those. I'll just be quietly working up here. We can compare notes in a moment, see what we come up with. What do you guys think?
Cosine theta
Good
times
question.
2 sine theta, or
Okay, hang on a second. Finish your question, Sam.
wouldn't the end of it be cosine theta times 2 sine theta for dy d theta?
And are we for dy d theta? So let's see here. So I did 1 d2 plus
Oh, wait,
2
no, I
d1.
no,
So
I looked it wrong. Yeah.
it'd be negative 2 times negative sine theta. So I think it's okay. So far I've just done the dy d theta. I haven't touched the dx d theta.
Can you simplify that one further?
Simplified in what way?
It's sine squared theta plus cosine squared theta.
Oh, interesting.
Theta.
Oh, you're talking about like the Pythagorean identity equaling 1?
Yeah.
Okay.
I missed the-
That'd be lovely if we could just erase the back half and say plus 2 times 1, right? That would be lovely. But yeah, we can't go that route. I'll work on the purple one real quick. See if I can fit this on the page.
I'm writing so small and I really don't think I'm gonna fit it, so.
Yeah, definitely keep writing small. Okay, let's see here. So
And the cardioids.
dx d theta equals
That's
1
fine. I got it.
d2
You know what? You're the one making it.
plus 2 d1
Just stop. I'm not going
And cardio would be mad special.
I kind of like that actually.
Oh, I don't think I can fit it.
Tell you what, you're pretty cute, but can you draw a cardioid really well?
I can't.
Is that like a pickup line, Jack?
Yeah. No, it's like a deal breaker.
It's
Deal
a,
breaker.
it's
If
a
you
deal.
can't draw
It's either an
cardioid-
icebreaker or a deal breaker.
It's both.
Okay.
So that's what the best icebreakers also count as deal breakers.
True, because you can figure it out right there. Yeah.
Okay, so do you have any detrimental personality flaws? Just trying to get to know you.
Yeah, and of course, the ability to draw a cardioid is clearly a flaw potentially. No doubt. Hey, are we okay with the black and the purple up there? I tried to go slow and not rush.
For the dydx, is that,
dyd theta, you mean?
sorry, yeah.
Yep.
For dyd theta, that, like, when you first wrote it out,
Yep.
is that just times 2 sine of theta?
It is, yes. Sine theta times 2 sine theta.
Okay.
Because it was really negative 2
Yeah.
sine theta.
Okay.
Yeah, totally.
That was so small.
Yep. Okay. So obviously this is an important point. We want to be able to get to this using the product rule. So now what we're going to do is we're going to work on both the horizontal and the vertical tangent lines kind of together, because we need to set both of these two equal to 0. Do you guys want to do the challenging one first or the easy one first?
Challenging.
Raise your hand for challenging.
Put your
I
hands
have
down.
Okay.
I'll give it out of the way.
We'll do what in my opinion is the more challenging of the two, and I would say that is going to be the black one. So I'll just continue this on. I'm just going to tag on. I hope you guys do the same thing. I'm just going to go, check it out, equals 0. Okay?
Wow.
Now I'm just trying to save myself some space. The question is, how on earth am I supposed to solve that?
Your calculator.
No, because this very easily could be a no calculator
Unit
question.
circle.
Eventually, yes, but not yet.
Okay.
Can you...
Leave it as it is. Great.
So let's get rid of the 2. I think that's a great idea. Divide everything through by 2 now. So you end up with this. It's going to make the numbers a little smaller. Do you see any other issues here that are standing in our way of solving this? Do you see what this is? Any observations?
It's a
It's a quadratic.
Oh.
Very interesting.
Wow.
I don't know, I'm just saying.
But it's kind of a weird quadratic, isn't it?
If we factored out a -1, we could get a trig identity, and there would.
Which trig identity?
If we factor out a -1, we could get cosine. Never mind, we can't.
Yeah, they're different signs.
That one's on me.
No, it's okay.
I was
like
thinking
it.
about it too. I was trying to figure it out.
I tried to do the same thing.
Like the idea.
So this
Sometimes you just make yourself feel like.
this looks very quadratic-ish, doesn't it?
Yeah.
But there's something that shouldn't fit. That seems like something doesn't
Complete a
belong.
square.
No, that's a good idea. It is a quadratic, and so that's a possibility.
I was so scared.
What is it?
There's 2 different.
The two yeah. So
I feel like X squared plus Y squared.
yeah, Julia, exactly. It would be like x minus x squared plus y squared.
Oh.
Wait.
You see what I'm saying? So it's like
Isn't that like the, almost the
You need
equation of
X,
circle?
Y. Or 2X.
well. So basically what I need is I need all of the same variable, right? I need like
R squared?
all cosines or all sines, right? So what could I do to make it so that it's all cosines or maybe all sines?
10.
Divide
by 0.
Divide by 0, no.
You can replace sine squared with 1 minus cosine squared.
That's why I was so interested to hear what you were going to say, because that's it.
Well, I'm not going to remember those.
So,
Mr. Anderson, do we have to know these things?
Now we do.
Well, yeah.
Mr.
No one can force you to know anything, but I will assess whether you know them or not. Let me put it like that.
That's not that bad, though.
That's not fair.
That's not fair. Please don't spend the rest of your life saying it's not fair. Okay.
That is a good point.
You
So
shouldn't be the one complaining.
what I've done is I've replaced this with that, and now using that Pythagorean identity, everything in my little quadratic is now,
Are we gonna have to know all the?
no, just the Pythagorean identity.
Just sine
That's from
squared
the
plus cosine squared equals 1. Oh, I know that.
That's what the.
We're not going to get into the half angle identities and the double angles. We're not going to, sum and difference.
Just checking.
Okay, so let's simplify a little bit. This would be -2 cosine squared theta plus cosine theta plus 1 equals 0. I just put it in the right order and added a couple of like terms there. Can you see any cleanup work that you would like to do before we wrap this one up? What would make it a little easier? Yeah, divide everything through by -1. Yeah, I agree that'll make this a touch easier. And I'm just going to erase on this step. So I'm going to erase this, and I'll make the other two minuses.
Great.
So now we're here. Now how would you break this down to solve it? Yay, factoring. That's right. So I think it would be 2 cosine theta plus or minus something, cosine theta plus or minus something equals 0. I'm pretty comfortable with that.
Oh my god.
How do you get the 1 and the -1 and all that stuff arranged? What do y'all think?
Has to be a plus and a minus.
One of them's got to be plus, the other one's got to be minus. Agreed?
Wait a minute.
Wait. Oh, wait. It's gonna be plus 1 and minus.
Plus 1?
It's gonna be -1 and then. Wait, no, not plus 1 and then -1.
No, it's plus 1 then minus.
Yeah.
In order, it's going to be +1, then -1. Agreed. Agreed.
Oh.
Okay, so you guys are all big boys and girls. So we're going to set each one of these factors equal to 0.
Mr. Anderson, I'm 12.
Here's where we're all impressed that you're 12 and in here. We're going to use the unit circle now once you've set each of these factors equal to 0. So based on this, this first factor, wouldn't it be cosine theta equals -1/2?
And that's not subtraction.
Subtract 1 divided by 2. And this other one over here would just be cosine theta equals 1. Okay, so what are our nice?
2 pi over 3 and 0.
Okay,
Papa.
so theta
Does
equals.
Santi know the unit circle or something?
Do you have the unit circle memorized or something?
Cool guy.
2 pi over 3. Yeah, because it's negative.
I don't want to talk about it.
That's okay, Jack. That happens to the best of us. You're right.
I think there's one more.
I think. Oh, there is.
I think there's
There's actually.
Guess not.
5.
So.
2 pi over 3 and
5 pi.
you went one too far.
4 pi.
I think it's 4 pi over 3.
Mr. Anderson, I have a question.
Oh, because
Yes.
You best believe I'll be drawn out.
And then the 4 quadrants
It's
and.
asking us to find all the locations of all the vertical tangents and horizontal tangents. Does that mean we have to do all of the coangles or not coangles?
That's a great question. We would limit ourselves to just like one time around. So I'm not going to say plus n pi or we're not going there.
Thank you.
Because the tangent line would all be the same equation there. Yeah.
We just do it from 0 to 2 pi. And then just.
Yeah, it's like if this were a quiz or test question, I'd probably give you a nice domain and say on this, and it's probably going to be 0 to pi or 0 to 2 pi. Yeah.
So I'm assuming we're not gonna be given the graph on the test, but in a situation where we did have the graph,
Yeah.
in any case on our calculator here, because those vertical tangents exist on the graph, don't we then not really have to plug it into dxt theta because we have 3 locations and we have 3 locations right there as well.
Well, we haven't done anything with vertical.
Oh,
This was all about horizontal.
So one of them is gonna be wrong.
So we're going to have an issue on one of them.
Okay, so
Agreed.
once we get one of them, would you on the test accept us not plugging in the other two because we know?
Well, on a free response though, like on a free response, like the directions at the start are always show complete work.
Okay.
So it can't just be, oh, and by process of deduction, I've just decided.
Okay.
You're going to want to show some evidence for whatever you're wanting to say.
Okay, we're getting another piece of paper for this one.
Okay, so this other, the purple one will go by a little bit faster, or at least space-wise will be a little bit easier. I'm still going to set this equal to 0. What would you guys suggest as a method for solving the resulting equation? Factor out a sign, and maybe even a 2 sign or something, right? Either way, it doesn't really matter. I'll just factor out a sine of theta. That gives me -2 plus 4 cosine theta. And without having to do all that substitution with trig identity stuff, we're in a pretty good place. So this would just be sine of theta equals 0. And then, of course, -2 plus 4 cosine theta equals 0. Significantly easier. So cosine theta equals 1/2, and sine theta equals 0. So if sine of theta equals 0, which angles are we talking about? 0 and pi. Yep. So theta equals 0 and theta equals pi. And can you already see the angle that's going to cause the issue?
0.
0, right? Because I've got
Which makes sense.
a 0 in both lists. So I think we can X that one out and say that's probably going to be that sharp point that we can see on the cardioid. And we can confirm that here in a second. And then what about when cosine theta equals 1/2? The result would be theta equals pi over 3, and the positive, sure, 5 pi over 3 also makes sense. Okay, so we could now do a quick conclusion and say that we have horizontal tangents when theta equals 2 pi over 3 and 4 pi over 3. What I want to do is sketch these angles in. Wouldn't 2 pi over 3 be roughly there? My picture is decent, right? It's close enough to see. Wouldn't 4 pi over 3 be about there? So I got these points of horizontal tangency right there that correspond with those angles that we're seeing coming out of our work. Then I would say that I've got a vertical tangent when theta equals pi over 3, and 5 pi over 3. And this is where Jack's idea he brought out earlier is going to come into play. So pi, of course, is straight left. So there's that one. That one was expected. And then wouldn't pi over 3 be roughly here? Go into that upper yellow dot. And then 5 pi over 3 would go to that lower yellow dot. So a couple things about that. Number one, your proposal that right side vertical line would just be the same vertical line due to symmetry is totally true. But you're getting that place of vertical tangency in two different places on the graph, both of those two yellow points on the right. So since this asked for where, for what angles are we finding these vertical and horizontal tangent lines, you'd want to list both angles. However, if it wanted to know the actual equation of that line, it's the same line over there on the right, isn't it? So you just say it once. You don't have to say that twice.
Would there be a question like this when we get the exam?
So probably not to this level of complexity, because can you all tell that we've spent like 30 minutes on this?
We spent 30 minutes.
Class is over in 3 minutes.
Oh, what?
Yeah.
You're kidding.
We have now. Don't pack up yet. Don't pack up yet. But yeah. So kind of the short answer to your question is no, because this would just take forever. But it would be like one little piece of it.
There'd be like
Find the vertical tangent line on this domain.
On this domain for this. Okay.
They would say this should take them 5 or 6 minutes instead of like finding all these. Correct. Skills, yes. This exact thing.
Okay, just making sure.
Yep. Okay.
Spends entire AP.
So are you guys okay with connecting the picture, like the graphical representation, with the analytical and with just kind of what you know about these so far? Okay. So let me just ask you then, we'll just extend this one little piece, and we'll do number 2 on Monday. So if I asked you to find, let's say I said, let's find the actual equation. We'll call this horizontal tangent number 1, like that top one. If I wanted you to actually find the equation for that, not just the angle leading towards it, if that makes sense, what would you do if you were going to try to find the actual equation of that green line?
You
don't,
get the x and y coordinates with the x equals.
And you don't even need the x and the y coordinates. You just need the y coordinate. If you just had the y coordinate, you're good. So let's try it. So y equals r, which was 2 minus 2 cosine theta times sine theta. And if I want to know the y coordinate at that horizontal tangent line, I need to plug in what angle? So 2 pi over 3. That gets me pointed up there at that top horizontal tangent line. So it'd be y of 2 pi over 3 equals 2 minus 2 cosine of 2 pi over 3 times sine of 2 pi over 3. And we're going to find out just how accurate my picture was or wasn't. So what's cosine of 2 pi over 3? Negative 1/2. Times negative 2 is 1. Plus 2 is 3, right?
You were pretty close.
So 3, and then sine of 2 pi over 3 is what?
Wait a minute, hold on. I'm computing.
Positive, yep, positive. I think Jack's right.
Dang it.
Root 3 over
I was
2.
computing. It just took me.
So the equation of that line would be y equals 3 root 3 over 2. And let's figure this out. Root 3 is roughly 1.7. Half of it is about 0.8-ish, 0.85, something like that, times 3. We're looking at about 1.5 or so. I'm a little too high. It's just a smidge too. Well, no, it's too high. It's too high by a
3
bit.
times 0.85 is 3 times 0.85.
That's not 1.5.
No, it's, that's right, it's like 2.5. I was close.
I told you.
And I messed up with simple arithmetic to get there. So it actually was a good
See,
one. Okay.
don't get down on yourself.
I appreciate it. Hey, have a great weekend, you guys. Polar. Who knew we could take like 35 minutes with one?
I did not realize that was 30 minutes. I thought
Oh, yes.
I thought that was like 10
So that is a thing. So there's the calculus of a real variable and there's calculus of complex variable. It has its purposes, including like electrical engineering, a lot of other engineering type things. Yeah. Thank you, Jack.
It's an active